was that?
Alright, so these tarps were used for a kind of a backdrop to hide all that junk in the background. Well, I just finished, finally, the Lincoln, and so these were done for like the final assembly pictures of the Lincoln to hide all the crap in the background. So now that we got the Lincoln out of my hair, I got 3 projects I'll show you, but we're going to build an engine, what do you call it, adapter plate, I guess is the way to word it. We're going to adapt a Kubota diesel engine to a Jeep transmission. Alright, so we're kind of crowded in here, and I'm trying to zoom out. So this is going to be an overland project. There's the Lincoln buried over there. There's our next big boy. That's going to be a 70 Cuda with a Hellcat and a Corvette suspension. And of course the low buck truck. So we're going to get back on those. But this is what we're going to do today. Now today's Christmas Day. And we're going to make an adapter to put a Jeep transmission to the back of this. Alright, so here's our Jeep transmission. I don't know anything about this Jeep. I don't know what year it is or anything. Surprisingly enough, the transmission says Ford, even though it's in the Jeep. So I guess there's a little bit of bestiality going on between Ford and Jeep, but whatever. There's the Corvette stuff that's actually going to go in the Cuda. And before any of you jump on that and say, well, that's just a Dana center, it is. And it's not going to be the center that runs in the Cuda. It's getting a Hellcat. And so back up to the Hellcat, it's going to get a Hammerhead Corvette center. Okay, so what's going to make this considerably harder than it should be is the fact that none of this is symmetrical to this. So what we're going to have to do is we're going to have to put the flywheel in. I'm going to have to double check that this is actually round. And judging by this point here, I'm fairly certain it is. So what we'll be able to do is we'll put this in the CNC mill, pick up 3 holes, and then from the 3 holes we can enter all that into the computer, and that will give us the center line of the crankshaft. And then from the center line of the crankshaft we can come back out, pick up all of these bolt holes, and then from there we can make the first of the adapter plates. And instead of using this big bell housing like it's got, I think we can get away with a plate. The guy who wanted this done, he wanted like a spacer put out here, the factory Kubota flywheel, take the Jeep flywheel, machine it to fit that. And I think that that idea is a bad idea. So what we're going to do is machine up like a plate that's probably 3/8 or 1/2 inch thick, and then just machine the entire Kubota flywheel down to basically nothing, and go from there. So what does work out nice is this one is round based on the input shaft. So all we will have to do here is touch off, find the center of that, and then come out here and find every one of these holes. Now the dowels are going to be the critical piece, and then the rest of these are still going to have to be accurate. They won't have to be down to the, micron here. However, it looks to me like this is going to be over the capacity of the machine, so I'm probably going to be able to get these ones here up to about here, and then these 3 here are going to be out of the capacity of the machine. The machine doesn't have enough travel to get to these. So I think what we'll do is we'll make the plate, and then these last 3 we'll just drill by hand. and it's in a Jeep. Figure that one out. Alright, so I got this clamped in the machine now, and after a little bit of looking at it, I realized that not all of these holes are mounting holes. These ones on the bottom are actually just cover holes. So the ones we need up here are going to be within the capacity of the machine. So we'll find the center of here, that'll give us that crankshaft center line. And then we'll find all of these holes here. And then we'll do the same with the other one, and then we'll overlay the two. Well, this is going to make it harder than shit to see the freaking H finder. Alright, so we got our first number, which is 4.652. So if we divide that by 2, 2.326. Alright, so we got a halfway point between there. We go to offset. And what we're going to do is, trying to do this with the camera's pretty hard. And we just zero that number. We got our first point. Alright, so there's our second number, which if we divide that by 2, we need that number. And now we have the center line of the crankshaft. Alright, so now what we got to do is find the center of this dowel hole. So now we got the first dowel hole. That is the center of the dowel hole. So what we'll do is I'm using G55 for the dowel hole. G54 is the center line of the crankshaft. So G55 is now the first dowel hole. So all I got to do is come into here and change that to G54, alter that, run that. Now go to hand jog, and there is the position of our first hole. Now the fun part, just write every one of these down. So I've got to repeat this process for every hole. Hole number 2. Alright, so all up, by the time I put this in the mill and go to all these numbers, it's about 45 minutes. And that one there was just out of the machine's reach, so whatever. I can do that one by hand. I'm using an old CAD system here. This is LT97. I bought this system in 1997. I'm still using it to this day. It works. So anyway, we're going to start with a circle right here, and then we'll just start with a 4-inch circle. That is our crankshaft center line. And now what we're going to do is we're going to take all of these numbers we wrote down. So we will start with a line. We'll come out from the center of here, and we will go 7.683 at 180 degrees, which is the same as a negative X. And then we are going to go 196 thousandths and 90, which is the same as a Y. And there's our first hole, which is our dowel, is right there. And those dowels were odd size. They were, what were they? Second dowel is 7.6515 positive X and 561 thousandths on Y. And there's our second dowel. Now I'll put all of these in, and then we'll rotate the drawing to get the transmission back straight. Alright, so now what we've got is we've got all of our holes. So we have now got all of our bolt holes and our 2 dowel holes laid out in the drawing. And then, it's kind of a weird angle. So what we'll do now is we will run a line from the center of that hole to the center of that hole. And as you can see, we have an angle, and that's how much the bell housing was sitting in the machine at an angle. And all we do is we take an angular measurement from there to there, and come on, there it is, 1.3635. So that was not a bad guess. So I'll write that down real quick. 1.3635. We'll erase that now. This is going to get in the way. And then we rotate everything. We rotate all of those around the center of the crankshaft, and we're going to go a negative number, I believe. Negative 1.3635. There we go. So we now know where all of our holes should be, and we'll save that real quick. I've got the bell housing off the back of that Kubota engine now. So what we're going to do is we'll find the center line, get the crank center line, just like we did on the other one, and then pick up all of these holes. And the problem is that this one is upside down. Because of this, it was going to limit the travel on the machine, so I spun it around. So what we'll have to do is draw this in upside down on the computer, and then 180 everything. Alright, so we've got an interesting problem here with the dowels. The dowels here are not horizontal, but judging by the bottom of the block, these 2 holes here are. So when we figure out all of this stuff, we'll use that as our horizontal position. So this makes it also a little bit more interesting, because I can't get all the way out to here to get the center. What I'll do is I will go from this point to that point, and that'll give me the center that way, and then I'll get the center on the X that direction. Alright, same thing again. We're going to half that 8.982, which is 4.491. That gets us a Y dimension. Okay, so the edge finder is 200 thousandths thick. So 14.051 plus 200 puts that at 14 1/4 and 1 thousandths. So 14.251. So we're dead nuts on the center there. Okay, so once again we've got the center line of the crankshaft, and now we'll come around and we'll pick all of these holes off, write them down, put all that into the computer. Alright, so I've got all of these holes now, but I've got this dowel here. For whatever reason, they did not through drill it like that. I don't know why. So I've got to flip this over 180 degrees, get some hole placement so that I can then get that dowel and then get the starter motor figured out. Okay, so it's upside down. So this is the dowel that we don't have the data for, and we need the starter motor data. So what we're going to do is we're going to pick up this dowel here, and we'll use that as basically our datum again. We'll pick up a couple of holes that we've already got the info on, and then when we draw this out on the computer, we can rotate the holes so that they're on top of each other, and that's how we'll get the information. So all we got left now is to get the hole for the starter motor and 2 mounting bolts for the starter. Alright, so there's all of those hole placements figured out, and that was about 3 hours to do all that. Alright, so there's all of our numbers, and we'll go back to the same process where we just make another drawing with all the bolt holes in them. Alright, so this is the Kubota engine now drawn out. These are all the holes I picked up. Here's our dowel. Here's our bottom holes that we're going to use as our reference to get our straight line. And I just did a quick measurement, and I was actually really close when I threw it in the mill. I was less than 3/10 of a degree off, so not bad. So I just rotated these, got this lined up. So this is the Jeep bell housing, and this is the Kubota, and what I just realized is this has to be mirror imaged because that is looking from the engine back and that's looking from the engine forward, right? Did I get that right? One way or the other. So anyway, I've got to mirror image that drawing before I superimpose it on top of that drawing. Alright, this represents a Jeep transmission, and that hole there represents the center line of the crank. This over here represents the Kubota engine, and that's the center of the crank there. So we're just going to superimpose the drawings. Now this is where it gets interesting, and it looks like we're okay. The dowel is the only thing that's a little bit close to the starter motor, but that's okay. The rest of these bolts are okay. So essentially all we got to do now is make us a round plate with these bolt holes. And the only thing that we'll do, because of the way the Kubota is set up in the center, is we'll take the center out of this, but it won't be a round hole. Other than that, that's all we need. Alright, so there's what we need as far as what our plate's going to look like for adapting a Kubota engine to a Jeep transmission. Okay, so we're going to take this monstrously heavy flywheel and machine it down now to fit the clutch for the Jeep. And unfortunately I've got this 4-inch cutter, and I don't have the right shell mill cutter to put it on there, so I've got this 3-inch one. Problem is, even with the machine travel, I'm going to end up with about 3/8 of an inch I don't get, so I'm going to have to do this twice just to machine the face of it off. Okay, so I've machined the one side down, just roughed it in. I took 2.4 inches off of it so far. So this thing was almost 4 7/8 of an inch thick to that point there. So, but I've got it roughed in. So now what I'm going to do is I'm going to actually sit down and do some math and get the true final dimension of this flywheel. Alright, so I measured to where I can see where the input shaft was wearing on this pilot bearing here, and then up to here. And I come up with 3.75, which is kind of an ironically even number. So after I take the width of this off, I'm now down to 2.156, roughly. So now looking at where I've got here, I've got 3/4 of an inch for the pilot bearing to go into. So doing some math, I come up with a depth of a total of 1 3/16, 1.188, close enough, half a thousandths. So after measuring this one, and then this step here and everything, I find that if I take this down, I'm going to take 640 thousandths more off, and I'm not going to be happy with how thick that is. I think that that will kind of limit me on my threads for the clutch. So I'm going to take, I think it figured it at 480 thousandths from this point here, this point where I roughed it in. So if I take 480 thousandths off, and then I make the pilot bearing step back a little thicker, and then I will make up the difference in the adapter plate. Okay, so I just measured the other flywheel for the bolt hole placement for the clutch, and it worked out nice and convenient. So it's on a, well, they call it PCD, but the diameter of this bolt pattern is 11 5/8, and 6 bolts and no dowels, which make it nice. So I just picked up that, and there's my numbers. That's all I need to know for the 6 holes. Okay, so we got one more cut to go here, and so the way the cutter's going, it's going clockwise here, and the idea of that is so that the cutter is cutting this way, so it's always cutting into the part. You don't want to go the opposite direction, because you don't want to risk, especially with cast iron, you don't want it to chip out on the edge. So by the cutter going this way, it's always feeding into the cutter. So we're going to do this last cut. We're going to come around with 2 clockwise passes, and then when we come into this one, we're going to turn around and go the opposite direction so that we don't chip it out in the center. So we're not chipping the center out or the outside out. So one last pass to go, and she's got to have the center redone, and then the 6 holes for the clutch. Now these holes will be in where the fiber's at, but it'll be just barely in, and I don't think they're ever going to be an issue. Okay, so what we're going to do now is we're going to reclamp this, and we're going to turn this so that these bolts are more in a 6/12 o'clock position, because we're going to have to balance this flywheel when we're done, so we might as well try and make this the least amount of work to balance it as possible. So we're going to drill the 6 holes for the clutch, and then we're going to open this piece here up big enough for the back of the clutch to sit down into there. Alright, so I'm just trying to get this relatively square. I'm not shooting for perfection. So all I'm doing is I'm just putting a framing square along the edge of the holes, and then just eyeballing along the edge of the T-slot. And that's good enough for what we're going to do. We'll clamp that down, and drill it. Okay, so I'm going to touch off in here and get the center. So there's two things. When you do something like this, and you got a surface that you don't want to scratch up, put a piece of paper under your clamps. Don't ever put a piece of cloth, because the cloth will move, which will let your part move. So this piece of paper, fold it over a couple of times, and that'll work fine. And the other part is anytime you're machining something, you got something that's spinning, you'll get like a small magnetic buildup. So always clean this before you go to check it with the edge finder, because there'll be chips in here and they'll be stuck to it. You may not see them, but it's enough to throw your edge finder off and give you a wrong center. Fun trying to tap one-handed and film. I got lucky with this pilot bearing. I figured I'd be machining it down. I guess I'm not, so. Can't complain at that.